Hey guys, we are going to start chapter 3 here. Chapter 3 is all about algebraic expressions. Okay, so we need to understand what is an algebraic expression. So an algebraic expression may contain numbers, operations, and one or more symbols. Okay, so here's an example of what we're looking at here. So first we have some definition terms that we need to understand. Okay, I will be using them in class and they will be all over homework and everything else. So the symbol that represents one or more numbers is called a variable. Okay, so it's always a letter. Okay, your variable is going to be a letter. Sometimes X, sometimes Y. Those are probably the most common variables, but we'll see things like you see P here, T, S, M, N, okay, any of those letters. Okay, so the numerical factor of a term that contains a variable is called a coefficient. So when this right here, okay, has a number and a variable in it, so the number part of that term is called a coefficient. Okay, so it's a number in front of your variables. A number without a variable, so just one of our normal run-of-the-mill numbers, is always called a constant. Okay, so that's what this 4 represents. All the different parts of our expression are called terms. Okay, terms are always separated by addition. Okay, so let's look at example 1 here, and let's identify the different parts. So we want to know what the terms are, the coefficients, the constants, and I added variable here so that we can also identify that variable. Okay, so terms, first of all, anything that is separated by addition. So 5x and 13 would be our terms. Coefficients, again, are just the number in front of variables. So the 5 is in front of a variable, so the 5 is the coefficient. Constants are just regular numbers. They do not have variables attached to them. So that would be 13. And then our variable in this situation is just an x. Okay, so let's look at part B. Try that again. Again, terms are separated by addition. So I have 2z squared, y, and 3. Coefficients, anything in front of the variable. Okay, so we can plainly see here that the 2 is in front of that variable. But then I have another variable, and there is a coefficient for that variable. It is what I call just one of our invisible numbers. Okay, so that's for if I have just a variable by itself, there's always an invisible 1 in front of it. 1 times a number doesn't change it. So mathematicians don't usually write it if we don't have to. So 1 is a coefficient there. The constant in this situation is just the 3, and then our variables are going to be z squared and y. Okay, you can pause the video and try some of these on your own and see how you do. Alright, so I'm going to put the answers here, so you hopefully paused it and now you are checking your answers. So our terms, our coefficient, our constant, our variable. Terms, coefficient, constant, there's 2, and then the variable. Terms, coefficient, 9, and that invisible 1, and we do not have any constants. And the variable is z squared and z. Okay. All right, so let's look at example 2. Example 2, we're writing our expressions using exponents. Kind of practice this in chapter 1 a little bit. If a number is the number that repeats is going to be your base, and then how many times is your exponent. So just a little reminder, so if I had like 2 times 2 times 2, 2 is repeating, and 3 times is our exponent. So here I am using variables. So the d is repeating, okay, so d is my base, and I have 4 of them, so that's my exponent. If I have a situation here where I have a coefficient in front of my variables here, okay, I'm still going to keep that coefficient. So I'm still going to have 1.5, and I'll have h as my base, and I have 3 h's. Okay. Here's another on your own. Please pause the video and try this and see how you do. Okay, hopefully you tried on your own. 1, 2, 3, 4, 5, 6, 6 J's. So I'm going to have J, and then to the 6th power, I keep my 9, and I'm going to have K as my base. 1, 2, 3, 4, 5 of those. Okay, so let's move on to example 3. Example 3 here, I have evaluating algebraic expressions. So here I have an algebraic expression because there's a variable in it. Okay, so I want to figure out my answer. So I'm simplifying. I'm telling you what K represents. So you have to substitute the 25 in for the K. So you're just like replacing it. Okay, it's not going to stay just a K. The K is now gone. It's 25. So 25 plus 10 is going to give us 35. Okay, so you're just replacing that number. Again, go ahead and pause the video so that you guys can try the on your own, and I will show you your answers in just a minute. Okay, so checking your answers here. So we have 24 plus C. C is 9. So I'm going to have 24 plus 9. So you want to add those two together to get your answer. What do you get? 33. Oops. There we go. Now I have evaluate D minus 17. D is going to be 30, so I'm going to have 30 minus 17. It's very important that you put it in the order, replace it, just follow it right below it. So 30 minus 17 is 13. Okay, so now what if I have two variables? So again, the instructions are going to tell us exactly what I need to do here. Okay, so I have A divided by B. So I'm going to substitute in 16 divided by, and we have a fraction. Okay, so we need to remember division with fraction. So 16 over 1 times 3 over 2. Okay, use your butterfly, simplify this a little bit. So I can divide that by 2 here. Okay, so 8 times 3 is going to give me 24. Again, there's some more problems on your own. Pause the video and try a few of these on your own. I'm going to go through and give you answers here in just a moment. Alright, so I'm going to start filling these in of what we should have. So 24 divided by 8 gives me 3. Q first, so 8 plus 24. I want to add those together. Then I have, okay, so 24 minus 8. And then this operation, these are two variables squished up next to each other. Okay, we talked about when numbers are squished up next to something, that means multiplication. So we are multiplying here. So I have 24 times 8. Okay. All right, example 5 here. So now I'm solving an expression that has two operations going on. Okay, so still same thing. If I have a number squished up next to a variable here, that means multiplication. So I can write it two ways. I can write it with my little dot, so I can put like 3.5, or sometimes when I'm substituting in numbers, I just use parentheses to represent the multiplication. Okay, so 3, and then I'm putting in a 5 here. Okay, so order of operations. You want to remember, please excuse my dear Aunt Sally. Okay, so order of operations, I am going to multiply first and then subtract. Okay, again, part B here, we're substituting in our number. So I'm going to have 2 as my z, okay, and it's squared plus 8.5. Okay, so if I have 2 squared, that's going to give me 4, and then I'm going to add 8.5 to it. That's going to give me 12.5. Remember, if I go too fast through these videos, that's okay. That you can always go back and re-watch things, okay? All right, so then the next one are just on your owns again, okay? So try these on, pause the video, try a few of them on your own, see how you do. So I'm going to go through and start answering some of these, but hopefully you pause the video so that you had time to try them on your own. All right. Okay, and the last one is a word problem, because I know how much you guys love word problems. So you are saving money to buy a skateboard. You begin with $45 and you save $3 each week. This one gives us the expression. Okay, so that's the expression. 45 plus $3 a week. It gives you the amount of money you save after W weeks. So first question is, how much money will you save after 4 weeks, 10 weeks, and 20 weeks? Okay, so you want to substitute in all that information. So first we're going to substitute in, so when W equals 4, so 45 plus 3, and then our W is 4, okay? So now I have 45, and then 3 times 4 is 12, and then add those together, so I have 57. So after 4 weeks, he saved $57, or you have. Okay, next, let's look at 10 weeks. Okay, so I have 45 plus 3, and then my 10. Okay, so 45 plus 30, 45 plus 30 is 75. So still not enough to buy that skateboard. Okay, and then let's try it for 20 weeks. Okay, so 45 plus 3 times 20. So we want to have our 45 and then get our answer there, so 60. And then put that down. All together. So after 20 weeks, can you buy the skateboard? If the skateboard is 125 and after 20 weeks you only have 105, is it enough money? So no, not enough money. Okay? All right. Your homework tonight, guys. All right, so you want to write down your page number and your problems, and then you guys can start working on your homework.